Welcome to InstrumentsDirect. Our program today is we're going to talk about magnetic flow meters. Water. Well, it covers about 70% of the Earth and it's vital for all known form of life. About 96% of the planet's water is found mostly in the ocean, the rest in groundwater, glaciers, ice caps, and is a key ingredient to life on this planet. Throughout the evolution of mankind, man has sought out means to harness the power of water and tools to control and to monitor it. Here we go. We have flow meters. Today's program is about magnetic flow meters, and we'll attribute this history behind this to an 18th century chemist and physicist, or back then known as a natural philosopher, who contributed to the fields of electromagnetism and electrochemistry. His name was Michael Faraday, and perhaps one of the things you recall back from grade school, Faraday's laws of magnetic induction. And in brief, Michael Faraday back in 1831 discovered that electrical current can be generated with a magnet field, or magnetic field. And about 100 years later, this theory is applied to electrically conductive liquids flowing in pipes and built the world's first electromagnetic flow meter. Hence, we use the term Faraday's laws of magnetic induction, which basically states the operation of a magnetic flow meter, or a mag meter as we call them, is based upon Faraday's law. And what this basically is, the voltage induced across any conductor as it moves at right angles through a magnetic field is proportional to the velocity of that conductor. And what in the world does that mean? Let's look at our diagram here. Here we have a piece of pipe. Call it our flow tube. And this piece of pipe, we are going to wrap around a bunch of copper wire. Do you remember back in grade school and science class when they had the old lantern battery and you had this big nail and some copper wire and you wrapped the copper wire around the nail, hooked up one leg to one side of the battery and another leg to the other side of the battery, and voila, you had an electromagnet. How about that? We actually learned something in science class back in the 4th grade and we're going to use it again. So in this case there, we have our pipe. We wrap around a copper coil here, and then we have two little electrodes here and here. Let's call them our voltmeter. And what happens with this application, these magnets create a curtain across the pipe here. And as the conductive media, here we go, water, goes through this curtain at a right angle, it creates a small current. These electrodes here and here measure it. The more that goes through there, the greater the current. So that's the basics of Faraday's laws of magnetic induction. So mag meters have some tremendous benefit in the world of measuring flow. And some of the neat features of this versus other types of technology is, of course, they have a very high accuracy and a wide turndown range. They're very durable, and they have little to no maintenance. They really don't have any flow obstruction because most of them are pretty much a straight shot flow tube, so there's any minimal or no pressure loss at all. They're not really affected by viscosity limits, and again, because they have really no obstructions, they're pretty good for most abrasive and corrosive applications. And there you have to monitor your materials of construction. Well, they are bidirectional because they can measure the gazinta and the gazetta. Most of them, as I said, are open flow tube design. And this particular brand we're going to look at today actually have empty pipe detection, which would be very helpful. And pile that on top of that, we still have some really neat perks that most mag meters require a little less than the traditional flow meters for monitoring straight run of pipe applications. What are the gotchas with a magnetic flow meter? Well, today it's limited to liquid applications. And we pretty much need a full pipe application with the models that we're talking about. And the liquid need to be conductive. So that's really the gotcha as far as the separations of different liquids. We need to have a minimum conductivity of about 5 micromoles or 5 microsiemens, depending how you look at it, as far as conductivity. So things that are not conductive, it's not going to work, such as any petroleum or hydrocarbon-based applications, or some other interesting things like deionized water. When deionized water is water with nothing in it. They take all the minerals out of the water, and the water is not even conductive at that point. So DI water and some RO water applications have very low to no conductivity. So those are really the only gotchas. Anything else that's really water-based, for the most part, is generally a good application. Now, the product line we have here, the Badger product line of the Mod Mag series, there is a whole bunch of different flavors there. The general purpose is Class 1, Class 2, Class 1 Div 2, Class 1 Div 1, batching, and so on. The 2 meters we're going to focus on today are the M2000, which is kind of like our backbone meter, and its sister, a battery version. So where, again, do we use magnetic flow meters? Before we said any water-based applications, and just to get your brain on the same track as mine here, which is probably impossible because you've never met my brain before. Typical applications, anything that's got the word water next to it is fabulous. So chilled water applications, hot water applications, glycol. Well, glycol is not conductive, but if you get more than 50% water, then we don't really care. So we'll understand if you have a majority amount of water with a mixture applications, it's usually not that problem. Makeup water, of course, domestic water, drinking water there. In the oil fields, we're not going to measure oil, but we love to measure fracking liquids there, which is dirty water applications, injection applications, well applications, industrial cooling. Of course, irrigation is a natural application. And on the industrial side, we have boiler feed water, boiler blowdown water. In the wastewater side, you'll see these as an industry standard in the raw sewage, WAS and RES, condenser water application, cooling tower wall applications. The mining industry, we now get into some slurry-like applications there, domestic reuse and reclaim water, chemicals, water for injection, just anything that's water-based, short pipe run, an aqueous application that's not a hydrocarbon is pretty much a good application for this type of technology there. So to break this guy down, there's 2 parts basically to a mag meter. And sitting on the top of this mag meter here, this is either called an amplifier, or I call it a transmitter indicator display, or the converter. So this device is your electronics basically here that will receive the signal, process the signal, give you some information. And down here, this is the flow tube. And this flow tube would be made up of, depending on the design, this design has flanges here, and then we have a liner. You can see the end part of the liner right here. And then inside that liner will be the 2 electrodes. And in this big metal can here, says there are copper wires wrapped around the pipe here, so to speak. So the breakdown of this is the ingredients. So this particular series, the M2000 series, M5000 series, these are some of the standard functions there. There are custom functions there, but it all comes down to delivery. So the majority of the marketplace is going to use either hard rubber or a Teflon or a PTFE, which is a Teflon-like material there, same properties as Teflon basically. And those are based upon the material compatibility of your application. The far majority of them are going to be hard rubber lined. The hard rubber liner is probably used more for abrasive applications. The Teflon is usually used for more higher temperature applications and more chemical resistance there. On the hard rubber side there, 4 inches and larger is NSF 61 certified or drinking water applications. PTFE is all sizes are NSF 61 certified. So you can use it for drinking water as well as any other process application. The standard electrode material is alloy C, which is a flavor of Hastelloy C. Hastelloy C is actually a brand name. It is not a material, actual material there, and has much higher chemical resistant properties, even better than stainless steel. So good stuff. Empty pipe electrodes that are in there Optional grounding electrodes are available. Long delivery, don't really want it because we can use grounding rings should you have a plastic application. The pipe sizes are a plethora of different pipe sizes there, and the adage of cost has dynamically changed in the world of magnetic flow meters in the last 5 or 10 years there. Back when I was a little boy, it used to be $1,000 an inch pipe ID, and now you can buy really big meters for just a few $1,000s. So the pipe point has really dropped dynamically, and the M2000 and the M5000 are extremely price competitive in the world of magnetic flow meters there. And secondly, if you pick the basic models, they are deliverable usually in about 2 weeks. So you can get a good price and you actually get a delivery for a mag meter. You don't have to wait 4 or 6 weeks and more for something to come over on a boat. The accuracy of the M2000, as I said, is pretty much our workhorse flow meter there, about 0.2%. The basic device has a hinge cover with external programming, very large display. So we said NSF 61 listed models. The basic model comes with 150-pound cast steel flanges there. You can either get it remote or integral. You have a choice of selecting either AC or 24-volt DC power. Some of the features, of course, did do an analog outputs, a NEMA 4X, bidirectional flow totalization, empty pipe detection, power loss totalization, and that's because we have a non-volatile program memory, so if you lose your power source there, it will retain the last bit of information, rotating cover, enhanced security options, and optional, you can actually add a data logger function to this device. And then there's additional options in communications if you wanted to have HART, Profibus, or Modbus output there. So it has a communication. So it has a lot of features for a very budget-priced magnetic flow meter. Moving on to the battery-powered side, it looks basically the same as the AC-powered side. It's only available from 1/2 inch to 24 inches. Accuracy now is down to 0.5%, and that's because it doesn't sample it as fast as the AC power version is, and you have choices of programming the sampling rate based upon the life expectancy of your battery in the device there. So if you have it take a sample shot every 15 seconds, you can look there, the battery's going to last for 10 years, which is longer lifespan than most flow meters, so I wouldn't worry about that. Digital outputs, NEMA 4 enclosure, empty pipe, and again, you can also have logging kits available too, especially with battery applications. The reason you're running off a battery is you don't have any wires. So if you needed to collect information there, the data logging function might be very advantageous. You can get it as an integral mounted piece of equipment, which means the electronics are sitting on the top of the meter, or you can get it remote. And when you get it remote there, then this guy turns into an IP67 flow meter. So you can put it in the metering pit and not worry about that. How much straight run of pipe do you need for this particular mag flow meter there? Generically speaking, from elbow to flow meter, if you have 3 pipe diameters before, so 3 after the elbow and before the meter, and 2 on the output of the meter before the next obstruction, you're hokey dokey for your basic application to meet your accuracy requirements. Should you have something very nasty before your flow meter, like a check valve or a glow valve or a butterfly valve or a big pump there, that's a little more disruptive than a 90-degree elbow, believe it or not. You need a little bit more straight run of pipe. In that case there, we'd like to have about 7 pipe diameters prior to the flow meter there. And so again, people ask all the time, pipe diameter. So if I had a 1-inch meter, for example, I'd need a minimum of 3 inches before. Or if I had a 10-inch pipe, I need 30 inches before, and so on. Some other interesting points there. Should you have a Teflon liner, you probably don't want to install this on the suction side of the pump, just in case we don't want to loosen the liners on that application there. Depending upon your particular application, but it's something to consider. This device is equipped with an empty pipe detection, which is very helpful there when there's no flow in the pipe. And so basically what happens when this device doesn't see any liquid between the two electrodes there for about 5 seconds, an empty pipe warning will come on. And then after that, basically, it will stop reading flow. When this, again, we have a connection between these two, then it will begin to measure flow again. So if you were to install it on a horizontal application, 3 and 5 is the best. This is wrong just in case you get a lot of crud on the bottom of the pipe here and you get air bubbles on the top there, and a vertical position really doesn't make that much difference. Should you have a vertical installation, no problemo. A vertical installation is fine. I recommend it, though, you use it on when the flow is going this direction. Flow falling down is a secondary choice, and every once in a while you get an application with flow going down, and depending if it's open to atmosphere, it can pull a lot of air in there, pull a lot of solids in there, might not give you the best accuracy for your application. So if you have a choice on a vertical application, flow up is my first choice. Now, plumbing this device into your existing hardware configuration. This configuration comes with a flange, a 150-pound flange. So basically, to install this device from flange to flange, you do need to have a mating flange and a gasket. The gasket is not provided with this device because there's all different kinds of gaskets, and we can make a suggestion. You know, you just go to Grainger to get something like that, or you'll have your own fittings there. Should you have an application where you have a non-conductive pipe material, plastic, PVC, fiberglass, in some cases cement-lined pipes, then it's probably a good idea to add a grounding ring to the application. In that case there, the installation using a grounding ring here, as we'll have the meter and your mating flange there. In this case there, we use the grounding ring or paddle and put a gasket in between the two, and you can hook up the grounding ring to the mag itself. Grounding ring, why use a grounding ring? A grounding ring will give you a good zero flow. That's why you use a grounding ring on a plastic-like application. And every once in a while you have an exotic application where you just have horrendous plant power, and the best thing to do then is also to ground your mag meter, and it solves a lot of problems there. There is a very expensive tool for verification of your M2000 or M5000 flow meter there. It is a bit complicated for most. It costs about the same price as buying your own portable ultrasonic transit time flow meter. So it's just another choice for field verification of your magnetic flow meter. And program your meter, let's just face it, this is a mag meter. And 9 out of 10 times out of the box, plumb it in line, power it up, and go home. And so that's most of the cases you're going to use a magnetic flow meter there. Should you need to trim something, in that case there's 3 buttons on the front of the display. Here's the picture of the 3 buttons there. This picture basically will help you scroll up or next step. This button here will help you use a down arrow or previous step. And this button over here is your enter function and the cursor right button. Again, we're not going to really belabor on any of this because there's not much you do. If you wanted to, say, maybe rescale your flow meter there, I mean, the meters are already programmed and set up when they go out the door. But if you wanted to rescale your 4 to 20 milliamp output, or you wanted to change the engineering unit, then you would go to the quick start or the quick setup, hit the start menu there and enter there. And this is where you can change the engineering units to liters from gallons or whatever else you wanted to do for flow rate there. And at the same token, if you wanted to change your totalization there, you wanted to go to pounds or you wanted to measure in barrels, this is where you could go and change your information again using the quick in function there. So very simple to do, not required in most installations. And that's the value of a mag meter. It is fabulous for the unfamiliar flow meter user. Plumb it in, power it up, go home. You want to use the output, it's already set up. Just take the 4 to 20. If you want to scale it to match a certain system, then you're going to need to scale the 4 to 20 milliamp output. Some of the neat things you can do, as we said, you can adjust the full scale, you can adjust the frequency output, you can adjust the low flow cutoff. Ever have one of them leaky check valves that you don't want to see flow dribbling through the pipe on reverse flow? Put a low flow cutoff in there. You can program it for alarm outputs. You can adjust the pulse outputs, and as we said, you can adjust the 4 to 20 outputs to match your recorder chart paper if you wanted to, or any other device that you have in your facility, should you want to. This particular device has an option. You can upgrade it with a logger. And the device, especially in the battery-powered side, as we said before, if you don't have any power and you need to collect some data, there might be another method to collect data is using a data logger. The dedicated meter, of course, has a 4 to 20 milliamp output, so you could add a logger, or you could use the onboard logger. And the onboard logger is very basic. It's designed primarily for totalizer monitoring and error events. So if you want to look at your daily totals, weekly totals, monthly totals, that's when you're basically going to take a look and use the data logging function there. To do that, you're going to need a data logging kit, and this data logging kit includes a logging token, the software, an RS-232 cable, and then we need to, no one else has serial ports on their computers anymore, interface that from RS-232 to USB so you can use the information there. So it's a very basic logger there, mostly used for totalization of daily totals and things like that. And monitoring your totalizer events there, this is basically the sequencing. You can, how often you take a sample. So these are the intervals. This is how often it would take a snapshot of data. And so once every 15 minutes, you'd fill up the logger basically in 104 days. Once an hour, once a year. So it's a fixed amount there. When you meet that point there, it'll begin to overwrite that data there as well. So again, if you want something that's much more intricate, we have many other loggers you can add to the system. If you wanted faster sample rate and more information there. So again, a very basic feature, a very economical choice with this particular device. And then as we said, to get the data out of the meter, we would use this RS-232 cable to a USB adapter and some supporting software to communicate and collect your data and to download your equipment. Calibration. The mag meter comes ready to go, factory calibrated out the door. If you want an additional NIST certification, multiple point, that is an option, but the factory mag meter out the door is ready to go for most all installations. Should you have an application that requires a periodic or an annual inspection, there's a couple of different choices. One, say you're in the municipal market and you need to verify your flow meters once a year. You can pull the meter out of the line, which is not a lot of fun, send it back to us, and we can do an annual calibration. Or, more practical, you can use tools in the field. Most economical way is to use a portable ultrasonic flow meter, which is another portion of our business there. You can rent them, you can buy them, and if you don't have them, the local services guy probably has one that does the field calibrations for a living. So there's a lot of people out in the world running around with portable technology that can come out and verify your magnetic flow meter. For the most part, it's usually a paper trail because most of the mag meters, unless the overall application affects the electrodes and gums it up, pretty much is a solid state device there that really doesn't wander very much. So the overall accuracies don't really vary unless there's some application parameter that's affecting the performance of the device over a long period of time. So if you need an annual calibration, you can use tools in the field as the most economical way to take a look at it. When it ships out the door, you don't really have to worry about it because it's already calibrated and ready to go. If you need some custom calibrations or custom regulatory people, then those are special options that you can get for certification should you need those for your particular application. So what did we learn today? We learned that the ModMag series has a variety of magnetic flow meters there. It has some basic requirements like most flow meters there. A little neat thing about the mag meter is it doesn't need the traditional straight run of pipes that most other flow meters require. 3 and 2 is pretty much the standard for most elbow-to-elbow applications there. it is a very accurate flow meter out of the box. So you don't need to futz with it. All you need to do is plumb it. You don't need to zero and span it for most applications, and just plumb it in, power it up, and let it go. Should you want to tweak and scale the 4 to 20 milliamp output to match your recorder or your control panel or your building automation system, it's a breeze. You just rescale the 4 to 20. The flow ranges of this device are pretty large. It goes down to about 0.3 feet per second up to, off the top of my head, 32 feet per second, something like that, or maybe 39 feet per second. I don't remember, but it's way up there. So the device accuracies are of rate, so you can't beat that for most water billing applications that they use in the municipal market. It's been an industry standard for well over 50 years. So should you need more information about magnetic flow meters, visit our website, go under magnetic flow meters there, and you will find information on the product. You will find operation manuals, startup, and should you have any questions about that, you would just give us a call here at InstrumentsDirect. So we are going to conclude the video portion and my stories of flow meters, and we're going to offer you, should you have any additional questions, call our toll-free number or drop us an email. Should you be chatting with Paul, one of our support engineers right now, continue chatting away. We'll leave the chat open for a little while longer. Should you have an application that you think that's appropriate for magnetic flow meters or having some issues with your magnetic flow meters, feel free to give us a call. Again, this has been Brent Baird for InstrumentsDirect. Thank you very much for attending our session today.